Good morning, everyone. Myself, Devikam, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthurakumar Institute of Technology. Today, we have learned about the subject W25C01 Basic Electrical and Electronics Engineering for second semester as per regulation 2025. Now, I am going to present DC fundamentals, which comes under Basic Electrical and Electronics Engineering. In this presentation, we will discuss basic electric circuit components, electrical networks, and series and parallel resistor connections. Introduction to DC fundamentals it deal with the basic concepts of electrical circuits operating with direct current. Understanding these basics is very important before moving on to advanced electrical and electronic subjects. Basic electric circuit components. An electric circuit mainly consists of three basic components, resistor, inductor, and capacitor. These components control, store, or modify electrical energy in a circuit. Resistor. A resistor is used to control or limit the flow of electric current. It opposes the current and converts electrical energy into heat energy. So the unit of resistor is ohm. The symbol of resistor is R. So the application for resistor is used in LED current limiting, voltage divider circuits, and heating elements. Next, inductor. Uh, an inductor is a storage device. It stores energy in the form of a magnetic field. It resists sudden changes in current. So the unit of inductor is Henry. The symbol of inductor is L. So the application of inductors are commonly used in transformers, filters, motors, and relays. Then capacitor. Capacitor storage stores energy in an electric field between the two plates separated by an insulator. It resists sudden changes in voltage. So the unit of capacitor is farad. So the application of capacitor are used in power supply filters, timing circuits, and signal coupling. Then electrical network. An electrical network is an interconnection of electrical components such as resistors, inductors, capacitors, and sources. So the electrical network are classified into different types based on their behavior and components. So it has active, passive network, linear network, non-linear network, bilateral network, unilateral, lumped network, distributed network, time invariant network, and time variant network. First one, active network. An active network contains at least one energy sources, such as a battery. It can supply power to the circuit. Example of active network is a battery connected to a resistors. Next, passive network. A passive network has no energy source. It only stores or dissipates energy. So the example of a passive network is a RLC circuit without a battery. Next, linear network. So in a linear network, all elements obey Ohm's law. So we know that the Ohm's law, so the output is directly proportional to the input. So the example of a linear network is circuit with fixed R, L and C. Non-linear network. Here, the voltage current relationship is not linear. So the example of nonlinear network is diodes and transistors. Then bilateral network. So the bilateral network, the behavior of bilateral network is the same in both direction of current flow. So example R, L and C circuits. Next, unilateral network. The behavior of unilateral network depends on the direction of current. So the example of unilateral network is diode circuits. Then lumped network. So all parameters are assumed to be concentrated at one point. So the example is low frequency circuits. Then distributed network. So parameters are distributed along the length of the circuit. So the example are transmission lines and the coaxial cables. Then time invariant network. The circuit parameters do not change with time. So the example is a fixed resistor circuit. So next one is time variant network. So in in a variant network, the circuit parameters changes with time. So the example is switching circuits. Then resistors are connected in series and parallel. First one, resistors connected in series. So in a series connection, resistors are connected N to N. So the same current flows through all resistors. So the total resistance, that means or effective resistance or another name is effective resistance and equivalent resistance. So these are total resistance denoted as RT. So total resistance equal to the sum of all resistance. So R1, R2, R3 resistors are connected in series means the total resistance RT equal to R1 plus R2 plus R3. So in the resistors in series, the current flows in same in resistors in series, but the voltage is divided across the resistors. The application is voltage divider circuits and current limiting. For example, resistor 1, 5 ohm and the 10 ohm are connected in series means so total resistance 5 plus 10 equal to 15 volt. Then resistors are connected in parallel. In a parallel connection, all resistors are connected across the same 2 points. So the voltage is same across each resistor, but the current is divided. So the total, how to calculate the resistance in parallel connection? So the total resistance 1 by RT, reciprocal of RT equal to 1 by R1 plus 1 by R2 plus 1 by R3. For example, R1, R2. 10 ohm and 10 ohm are connected in parallel means 1 by R total equal to 1 by 10 plus 1 by 10. So R total equal to 5 ohm. So in parallel connection, the same two resistors are connected in parallel means the half of the value is the total resistance. So uses in house wiring and current sharing circuits. To conclude, we have discussed basic circuit components, types of electrical network, and series and parallel resistance connections. These concepts form the foundation of electrical and electronics engineering. Thank you for your attention.